Okay, we are recording. Hello,
Okay.
camera.
All right, we're gonna go ahead and get started. It's good to see you all again. And I'm very happy to report that we can sit more comfortably now. And hope you all can hear me. We had some issues with the mic, so I'm just gonna go ahead and yell. And I hope everybody on Zoom can hear me as well. Thank you guys for coming as well. But without further ado, let's get started. We're gonna be doing. We may want to unmute ourselves.
We're good. We're good. We're good.
I think we're muted.
Nope, we're not.
Okay,
We're
excellent.
good. I
Let's
fixed
get
it.
started. So welcome back. If you guys recall, last Thursday we did Web 1 where we did like some inspect element. We talked about the browser. We laid out a very high level framework for how the internet kind of works when we make requests to server. Today we're going to give you guys some very dangerous information, and of course we ask for you never to use it in ways that you're not allowed to. We're going to give you guys some websites which you can hack, but today it's going to be all about hacking the server, right? We're hacking the website as opposed to strictly focus on the client or the browser. But before we get into that, let's talk about some announcements. So congratulations to everybody that was at Seesaw. We placed second. So that was huge. There was a huge effort from everybody. I can see a lot of people out here that were there. And if you want to see how that went, we're going to be going next this coming Sunday. We're going to be doing a Seesaw recap. We're going to probably go solve a couple challenges, talk about how it went, and we'd love to see you guys at the next CTF that we play. Overall, it was a blast. I cannot believe that we placed second. It was a wonderful effort from everybody. Also talk about a fall recruitment event. So in about a month from now, maybe a month and a half, it's kind of early to make this announcement, but we're going to be having a fall recruitment event. It's going to be like a CTF. We're going to hopefully have some recruiters out there. We're definitely going to have pizza one way or the other. And so I encourage you all to take the skills that you guys learn in these meetings, and you'll be able to apply it there. It's almost like an internal competition, but it'll be fun. Let's hit next slide.
We had announced a recruitment event for late September. We're going to push that back. That way it can be even better. So we're going to replace that with something. So more meetings.
Right on. So let's get started with this meeting. Here's the meeting flag. So if you guys all recall, head to ctf.sigpwny.com. Type that in for the meeting flag. I'm going to give you guys just a couple minutes to do that while I get a drink here. And while you do that, read the comic, and I'll go ahead and explain that here in a sec. Is there a clock somewhere? I think that's 5 minutes fast, right?
Yeah.
Okay, great. All right, while you guys do that, let's read this comic. So this is hilarious. It's an XKCD comic. This is the premise of what we're going to be doing today, where we give bad user input to a website, and that bad user input is going to somehow manipulate the database, or at least the response from the database. And in this comic, she named her son supposedly some very strange string, Robert dropped table students, which we'll understand what that does in a sec. I know some will laugh so they've understood it. But essentially, when the school typed that name into the database, it destroyed the school database of students. So funny joke there. Let's move on. Okay, so today we're going to be going over 2 web attacks, and I want to emphasize that they're completely independent of each other. So I'm going to be giving you guys 2 very independent attacks. I don't want you guys to mix them up at all. They're both like very popular, I'd say they're common. They were more common a couple years ago, but they're still very common today. So we're gonna start with SQL injection. We're gonna go over what SQL is. First, we have to have a little bit of background knowledge in that before we can talk about the injection part. And then we're gonna do some cross-site scripting, which is gonna be from JavaScript. So we'll do a quick JavaScript recap, talk about the injection, look at some examples. If you guys are on ctf.sigpwny.com and you already know some of this stuff, feel free to start those challenges. But if you're not, we're gonna go through those and you'll figure out how to do the challenges by the end of this. So next slide. Excellent. SQL injection is what we're starting with today. Let's the next slide. And to understand SQL injection, let's start with an overview. What is SQL? And I understand some might pronounce it SQL or SQL, and that was the joke for today's meetings flag, but I'm going to say SQL. It is a language which is used to store or retrieve things from a database. So if I'm a website and I saw you just requested to log in as a user, I'm going to say, I need to somehow query my database to say, does this user exist with this password? Right? And the way I express that is through a SQL statement or a SQL query. And that query is expressed in the SQL language, which we're going to see an example of in just a sec. Here's an example of the SQL query, right? And so this is an example of when I want to log in as an admin, and my admin password happens to be password because it's very poor at security, right? And so let's break this down. Next slide. The first thing here, select star from, says, give me all the rows or give me every entry from next slide, the table or the section of our database that stores the users, next slide, such that the following holds, next slide, where the username field of my user is equal to my user supplied input that is admin, and the password of that user happens to also be password. Okay, and that's going to return some elements if we have an admin or user with that name, admin, and password. So let's look at it in context. Where is this used? In a website, right? So here is an example of a bad code, right? This is vulnerable code that's vulnerable to SQL injection. Here is PHP. So PHP is a language you may not be familiar with. It's a language which is used in website backends. So the server, right? It's going to help process your request. And so this particular part of this PHP script handles logging in. We can see that we create two variables, username and password, and they access this post variable, which happens to be user submitted data, right? So let's say the username and the password are from what the user submitted. Now let's build our SQL query. Take a note that it looks exactly like the previous slide, but everywhere that we said admin and password, we replace it with whatever the user gave us. That's the important part to realize. I'm going to take my query and I'm going to construct the query with the user supplied input, right? And then afterwards, it's going to do some stuff with that data if it found the user, right? And if there is no user with that username and password, then it's going to be like user does not exist, right? So the thing to observe, let's hit the next slide, is that our user input is directly inserted to the query. So the natural question is, what can we put for our username and password which will make this program misbehave? So now it's time to get a little bit clever, right? So we have our SQL query here, which we've seen a lot, right? Select all the entries from our user table. One second first. From our user table, where the username is a supplied username and the password is supplied password, right? Can anybody think of a username which would make this misbehave in any way, right? Let's think of some examples. If I put a long string in, maybe that would be bad, right? If I put no string in, what would the resulting query look like? What if I put in a single quote, right? Will the SQL statement still be valid if I put in a single quote? It won't be, right? That's an invalid SQL statement because there's going to be 3 quotes right there. It'll be quote, instead of username, if I put a single quote, it'll be quote, quote, quote. And when the SQL parser tries to read that, it's going to be like, this is not a valid expression, right? Imagine like a compilation error, right? That's the consequence of directly inserting user input into our query. Now, we can get clever about this. Instead of just crashing it when it reads our input, we can get clever and manipulate the result of the execution of that query. Let's hit the next slide. Yes.
Is this like in Seesaw there was this long where you entered a number which was way higher than a long and you made it crash and like you extracted some value like that?
Oh, I understand. That's a little bit separate. So this is particularly on a website, and that would be something more for like an application.
Okay.
And so the same thought process though exists. Like what user input can we do that would make it behave differently than expected? So that same thought process holds. We're just gonna do something a little bit different here. That's a really good observation. Yes.
We also got a question from Zoom chat.
Okay.
So shouldn't they also be hashing the password?
Yes, exactly. That's a great observation from the Zoom. So consider the case where this database is hacked. We're gonna get to this in a bit. If I'm able to read all the passwords from the database, then that's it, I win. But we can talk about it later. It's not in this meeting, but if you were to hash the passwords, regardless if I hack the database or not, I'm not going to get your plain text password. That's a good observation. We should hash that as a conversation for another time. Okay, let's all try to use our imagination here and imagine if I say my username equals admin, single quote, minus, minus, what will the resulting expression look like? And my password can be anything. I want to first preface this by saying, if I have two dashes, that's like a line comment, right? So in Python, that's like a hashtag. Here's my comment. In C or C++, it's like // here's my comment, right? So it's going to ignore the rest of the line, right? Let's step through that. Go ahead, next slide. Okay, here's what happens. We're going to take the username and we're going to replace it exactly with our contents. Can anybody see where this is headed? Can you see how we're already changing the semantics of our query? Hit the next slide. Okay, what just happened, right? So our quote that we have in our string of our input has terminated the quote that they have in the query. And then when I say admin and I add another one and then that quote, and then I put a dash dash, that's a line comment. So it's going to ignore everything else in that to the end of that line, right? So Hit the next line. Slide. And then this is what our resulting SQL query transforms to. Can anybody read this and tell me what expects to happen now in relation to our database that we talked about? You get to log in as admin, yes. And what if I don't know the admin's password? Is that relevant now?
Doesn't matter.
Exactly. It's not even relevant if I know the password or not, because this SQL query just says, give me all the users where the username is admin. And there's no case where the username is admin and the password is the admin password. That we got rid of that because we added a comment, right? And so that's the concept. That's the premise of SQL injection. Our input can change the semantics and result of SQL queries. Does that make sense to everybody? That's really if we get over that bridge, then we're home free. Does that make sense to everybody? Can we visualize that injection and realize that that changes how the parser interprets it? Excellent. That's really the big takeaway here. There are lots of techniques which we can use, but that's really the premise. Let's hit the next slide. Great. Okay. So now let's look at SQL injection techniques. Like, what do you see when right when we're trying to exploit something with SQL? And the basic is going to be to log in as other users by changing the where clause semantics, which is what we just did, right? Where now we changed where username equals admin and password equals password. We changed that to just be where username equals admin. Right, that's the trick. Remember that string, it could come in very handy. A very common exploit string is to always make that condition true, right? To get all users. And that would be like saying, end quote, or 1 equals 1. Because or 1 equals 1 is always true. You change the where clause to always be true. It's going to give you the first result, which may or may not be the admin, right? Another good thing. So use this concept for the SQL 1 and 2 challenges. Okay, and then there's going to be the next concept, union, which we're not going to spend too much time on because I want to make sure we get time for the challenges. But the union is going to be an approach which you can use to exfiltrate other information about the SQL database, out of the SQL database. So, in other words, SQL injection is not limited to just logging in as the admin without their password. It can also extract all the user information from the database. So when you read in the news, like, website's been hacked and 50 million credentials released and credit cards numbers and their passwords, it's very possible that they just had a SQL injection vulnerability and the hacker just uses some union techniques to enumerate all the results of the database and was able to read that. It doesn't even have to be in the same table. So I'm not going to go over that today. We're just going to stick with the basic SQL, make sure we all get comfortable with that. If you want to explore that, I will be around, able to help you guys out with SQL free. Okay, and then also blind. So what if we weren't able to see the result of our query, right? And so for the SQL 3 chal, if we inject, we can see that the results change. But what if we are able to inject something into a SQL statement, but we can't see the results? We don't know if we logged in or not. We don't know if we got the username and passwords leaks. And sometimes you can get very clever and you could have a SQL statement which sleeps for 5 seconds if the first letter starts with A, right? And we enumerate them. And if we slept, we know it starts with A. And then from there, we can brute force, passwords character by character. You can get very clever with the SQL statements. But I want everybody to understand just the concept, how that SQL injection works. We're stick with the basic for now. Talk about SQL map. So SQL map is a tool which does this all for you, right? And so as much as I want everybody to do this by themselves, it's always good to start manually doing this by yourself. SQL map is a great tool to use. But sorry, I put CAPTCHAs on the first and second challenges, so you can't actually use SQL map on the first and second challenge, but you can use it on the third challenge.
Also doesn't always work. Like sometimes sites will just be a done with SQL map.
Yeah, yeah. It may not always work, but it's a very effective tool. Do not use it on any website unless you want to get the feds knocking on your door. That you don't have permission to. It's very noisy, so it can be easily detected. Okay, all right. That's SQL and SQL injection. Any questions on that?
What's a prepared statement and how to use it?
Okay, so right, we're talking so much about exploiting SQL injection vulnerabilities. We don't talk about what the correct method of implementing SQL statements should be. And so Michael brought up a great point about using prepared statements. And so prepared statements is a way to just completely eliminate the problem of injection altogether. We can just say that let's create a prepared statement, and we know that we're going to insert into the username and password fields our user input. And whatever tool that is going to construct a query from our prepared statements will properly sanitize the user input, right? And so whenever I say sanitize user input, I mean, don't trust user input to not mess with your query unless you A, eliminate all single quote characters, eliminate this, eliminate that, make sure these literals, aren't present, escape things. And it's a very complicated thing and often has bypasses, but using a prepared statement is the go-to way to do this. Thanks for that, Michael. That was a good observation. So that's how you do it. If you ever write a SQL statement and you're looking for the database, you don't want to get hacked, use a prepared statement. Okay. Next slide. Oh, right on. It's already XSS time. So I want to take a quick breather, and take a step back and make sure everybody understands those concepts. And if you have any questions, ask now. Zoom chat, speak up as well if you're interested. Let me get a quick drink. To clarify, SQL is all about hacking the website, right? So that PHP code, that SQL query, that's executing on a server, right? Not on our browser. Like that's far away from us. That's where all the users and stuff are stored. That's what we want to have. XSS is going to be different. Okay, great. No more questions. So that means that everybody now is able to take on the SQL 1 and SQL 2 challenges on the SIGPwny site. So feel free to take a look at those, or let's get into XSS. So XSS is completely separate from SQL. I don't want you to get the two confused. Even though the premise is similar, can we inject input into something to make it misbehave? It's completely independent from SQL injection. It's a completely new mindset. So let's start fresh and talk about cross-site scripting, which is what XSS stands for. The premise of cross-site scripting is to execute JavaScript on a web page where there shouldn't be JavaScript executing. And the result of having XSS on your site is that I can probably steal your login information, maybe steal your login information. I can imitate actions taken by a user, and I can read the contents of a page that the user is on. Okay, we're going to look at some of those examples here in a sec. But first, go ahead, next slide. We need to do a bit of a JavaScript recap. So if you're at the first week, you remember I talked a bit about JavaScript. And JavaScript is a programming language that runs in the browser to make websites interactive. And so here's an example of a script tag, right? This is what I embed in the HTML script or the HTML file, which will put this JavaScript that I have here and execute it, right? So remember these script tags. This is used in the context of an HTML file. This particular JavaScript just says that whenever my mouse or my cat is clicked, then say meow, right? You can look at that and see that. Let's look at a site that's vulnerable to cross-site scripting. On the left, I have an Express app. So this is written in JavaScript, it's running on my server. And my server says, okay, whenever you, the browser, go to something.com/view, right? We can see the /view here on the left. Then read the message from the user and render this HTML, but insert their message between these, I think, paragraph tags. I think that's what the P means, but I'm not sure.
Yeah.
Great. Okay, great. Paragraph tags. And here again, we see some sort of injection idea, right? So take the message from the user, display that back to the user in an HTML file, right? I think we can hit next slide. Okay, so the question is, what can we put as a message which will make this website misbehave, right? That's the adversarial mindset. What can we exploit here? And the answer is to put script tags, right? Next slide. What if our message looked like this? What would we expect to see? If I go to something.com/view and I have this message, then according to whatever templating utility I chose, it's going to say, okay, replace these inner angle brackets with this message directly. Put that right in there. And now I have JavaScript executing on my page when there was no JavaScript originally. That's not good, right? Let's hit next to see that happen. And so we can just see right here, looks like there's some formatting issues, but that's unrelated. Probably need to increase the size of my text box now. But anyway, it just embeds it right there. And then, go ahead, next slide, Chris. And then when it sends me to that page again, it says hello, right? So it alerts hello. But there's so much more we can do with that JavaScript. What if we said, steal your cookies, which were, if you recall from the first week, was that important information that saves your login token, right? That's how the website knows that you're logged in as whom. And so we could do that. Or we could say, redirect this user to the endpoint, which pays me $5 million from their bank account. What if it was on a bank account, right? I could do that as well with JavaScript. The important part now is going to say, now that I found this XSS, how can I get my victim, the administrator, to load/view with this message? And that's probably going to be me saying, hey, hello, admin. Please click on my link. And the link is going to be something.com/view and message equals script hello, alert hello, right? And then the admin clicks on that and the JavaScript executes because of a bad website implementation. And then I steal his data. I get paid $5 million, right? What's the next slide? Okay, just like the SQL techniques, we have a couple of classic cross-site scripting techniques. I encourage you guys to take note because these are going to be used for cross-site scripting challenges 1 and 2 and 3. So the first one is a classic, right? How do I check if the website's vulnerable to cross-site scripting? Well, I can just put script tags in it and say, say alert 1. And if I reload the page, it gives me a pop-up. It's vulnerable to the most trivial of cross-site scripting. I hope I haven't said SQL injection when I meant to say cross-site scripting before. Just cut myself now. And then a lot of times, though, there are some protections, right? So this could be some sort of protections. There are actually many protections against cross-site scripting. It's getting harder and harder to find these in the wild, but they do still exist. Some protections, very primitive protections, may just remove script tags from your input, right? And so that's the premise for the second cross-site scripting challenge. What happens if I don't have access to script? Well, check out this other clever thing I can do. I can specify an image, right? These are all HTML. I'm injecting HTML with the purpose of executing JavaScript, right? So I inject an image tag, which has a valid thing to load. And I say, when it's loaded, execute JavaScript, right? And this has no script tags in it, but it will still execute my alert nonetheless. So there's also a very popular way, and probably more popular than the way I just showed you, is to say image source equals some invalid URL and say when there is an error, on error equals alert 1. And this will also execute JavaScript on your page without a script tag. And then there's also this insane concept of SVG cross-site scripting. And SVG is some sort of image file for now. Let's just consider it as an image file. But when loaded in the inappropriate context, you can also embed cross-site script. You can also embed JavaScript into this quote unquote image file, depending on how it was loaded on the site. That's not something you have to worry about. I just want to make you guys aware of it, that there are plenty of ways which I can cleverly put something which will execute JavaScript. Next slide. Okay, we kind of talked about this before, but I want to drive this point home. Why is XSS bad, right? Cross-site scripting is bad because if I send a link to the administrator, which executes JavaScript on their page, right, with that .com/view with my message, then I can execute any interaction as the administrator on that website, on just that specific website. I can steal their cookies, assuming they don't have some other security set up. So, and I can read the page contents, absolutely. And talk about that. And so why is cross-site scripting necessary, right? Why can't we just send them to my site myevil.com and have JavaScript there to make them do stuff, right? That's a question. Why are we jumping through so many hoops to just execute JavaScript on the admin, right? When I can just send them to my site with JavaScript. And the reason is because browsers will protect cross-origin things. So origin being the domain that you're on, right? So if I'm on google.com, I am unable to say fetch or look at the resources for bing.com and let's read the result of that request. That's because it's cross-origin, or in other words, the domains aren't the same. So if I have evil.com and I want to send him over to bank.com/paynathan $5 million, the browser can be like, I'm gonna stop that right here, right? Because it's not in the same origin. But when it's cross-site scripting on bank.com and I'm able to run JavaScript on bank.com/view my message, remember we talked about that? That is totally okay for them to say, go to bank.com/paynathan $5 million. And it's like, oh yeah, that's the same domain. So it's totally chill. Let's pay Nathan $5 million. If only, right? That's the concept of cross-site scripting. That's all there is to it. So any questions on that?
Summary of like most of what they teach during web in 461.
Yeah.
So, sorry, it went a little long. This was going to be like a Sunday meeting, so we turned it into a Thursday meeting.
Yeah, and I want to finish off by saying that these are tougher concepts, right? We're getting into some tough concepts, but I know that you guys can all do it. We have very accessible chals right now on the SIGPwny site, and I'll be around. We'll make sure you're able to finish those. XSS 1 and 2 and SQL 1 and 2, you absolutely can finish today. SQL 3 and XSS 3 is kind of like an exploration you guys need to take to continue to study this, because a lot of things, techniques you use in those, we didn't necessarily cover. Any slides left? Yeah, okay, I should have had this slide up, right? And yeah, so I wrote these challenges. I put in some fun lore. So don't just solve the challenges, you got to read the fun stuff. So yeah, enjoy, guys. So I'll be around. Stop me anytime. We have a lot of people up here that would be able to help you solve challenges too. So get on that. Oh, last slide. Last slide. This Sunday, we're going to be talking about Seesaw. Do solve a couple of challenges for that. And then next Thursday is Introductory to Crypto. So hopefully we're back on the schedule where we have, accessible meetings on Thursdays and more in-depth meetings on Sundays. This is kind of more than more in-depth meeting, and our schedule just kind of was rearranged. So,
You know what? We got second in Seesaw. What can you say?
all right, have fun, guys. I'll be around.
All right. Pause the recording. All right, Zoom. Hi, Zoomers. We're here to help you. I'm going to pause the recording now, though. Hi, Zoomers. Again, reminder that the next meeting is this weekend. It is Seesaw Recap. It'll probably be in the SIF. And then we're going to show solutions to some of the challenges, go through photos, all of that. And then next Thursday will be crypto. So that's going to be like the fundamentals. And then probably the weekend after that will be crypto 2, which will be just like the advanced stuff. So thank you so much for coming. Have a great weekend. See you hopefully Sunday at the SIF. All right, I am going to end the recording by YouTube. Make sure to like and subscribe.